Imagine a world where volcanoes never sleep. Welcome to Io, Jupiter's fiery moon. You might remember our short about tidal planets. Io is one of those tidal moons, and that's a big reason why its volcanic activity is absolutely wild. Let's take a closer look at this fascinating little world. Io was discovered in 1610 by the famous astronomer Galileo, using his revolutionary telescope. Back then, it was just a tiny dot orbiting Jupiter. Today, thanks to modern telescopes and space missions, we have stunning photos and a wealth of information about this incredible moon. Io has a diameter of 3,643 kilometers, slightly larger than our own moon, and it orbits Jupiter at an average distance of over 400,000 kilometers, a bit farther than the distance between Earth and the moon. But think about this, Io is orbiting Jupiter at roughly the same distance as our moon orbits Earth. Sounds normal? Not quite. Jupiter is massive compared to Earth. This creates enormous tidal forces that constantly stretch and squeeze Io, because gravity pulls harder on the side facing the giant planet than on the opposite side. As a result, Io is literally being squished and dragged all the time. This generates huge tension just beneath its crust, and trust me, this little detail will be very important later in the video. You might be asking yourself, why is this moon so special? We have volcanoes on Earth, what's the big deal? Well, get ready, because Io is by far the most volcanically active world in the entire solar system. Over 400 active volcanoes constantly erupt, shooting jets of sulfur and sulfur dioxide up to 500 kilometers high. The constant tidal stress beneath Io's crust makes its layers slide over each other, creating intense friction. This produces incredible amounts of heat, melting the rocks below the surface. As the magma forms, it expands so much that it can't be contained underground. Eventually, it forces its way to the surface, forming a volcano. And when the stress is extreme, the volcano can erupt with jaw-dropping intensity. Volcanoes on Io create what are called paterae, crater-like features with flat floors and narrow cliffs around them. They're somewhat similar to the calderas formed by extinct volcanoes on Earth. The difference? Scientists aren't yet sure if paterae form the same way, from magma chambers emptying beneath the surface, or if a different process is at play. Paterae are also much larger than Earth's calderas and often aren't located directly on top of a volcano, but slightly offset. The largest known paterae is Loki, with a diameter of 202 kilometers. That's almost big enough to cover the entire state of New Jersey. And sometimes, these paterae fill with lava, forming incredible lava lakes. Keep in mind, Io's volcanoes operate on a whole other level compared to Earth. One eruption can unleash as much energy as 6 times the total output of all the world's power plants combined. The lava is much hotter too. All this volcanic activity constantly reshapes Io's surface, changing its colors and forms. In fact, Io's landscape is never static, it's a world in perpetual motion, molded by lava flows and eruptions that redefine it day by day. Io has an extremely thin atmosphere, made mostly of sulfur dioxide, with a pressure just 1/1000th of Earth's atmosphere. This would actually be great news for any hypothetical rockets landing there. The air is so thin that friction is almost non-existent, meaning no need for a heat shield. The atmosphere is constantly escaping into space due to Jupiter's powerful magnetic field, but the moon's erupting volcanoes keep replenishing it with fresh sulfur dioxide. And that wraps up today's journey to Io, a truly crazy world of lava lakes, explosive eruptions, and a surface that behaves almost like an ocean of rock. This extreme moon is just one of the countless wonders waiting for us in space. I hope you enjoyed this video. Let me know in the comments if you want more fascinating space adventures, and don't forget to like and subscribe for more cosmic journeys.